Hello, fellow students. Today we are going to work on the Greibach normal form. So we are going to review the basic theory, and we are going to see some examples and the different steps that you need to follow to transform a context-free grammar in its Greibach normal form. In the following videos, we will complete some exercises on this topic. Okay, so let's start. I will share my screen now. Okay, so Greibach normal form is a form of a grammar where the right-hand sides of all production rules start with a terminal symbol. So as you can see in the example, right, this is like the template for this form, and as you can see, we start with a terminal, and then we can have a combination of terminals and variables. Here in the example, you can see the right hand of the productions. As you can see, they start by a terminal, right? And then we have a combination of variables. You can have one variable after the terminal, or you can have none. Or you could have many. So this conversion, Greibach normal form, can be used to prove that every context-free language can be accepted by a real-time push-down automaton. In this case, the automaton reads a letter from its input in every step, right? So let's say that this form will be useful later if we work with push-down automatons, right? This could be like the first step. Now, if we want to transform a context-free grammar, any context-free grammar, to Greibach normal form, to this, we want it to have this kind of shape, we need to follow 6 different steps. So the first step is to remove lambda productions or epsilon productions. It depends on the naming convention that you use. And then unit productions and useless symbols. Well, this last part, it's optional, removing useless symbols, but it's better if you do it, because you will simplify the grammar. I won't go into detail on this step because I'm planning on doing some exercises in the channel, to upload some exercises on this specific topic, because this is something that is useful also to transform a grammar to Chomsky normal form. So as we will need to use it in several different things, I'm planning on uploading more exercises. I'm planning to upload more exercises. So after simplifying the grammar, the next step is to order the variables that we have in the grammar. You can, the order is from, let's say, from the lower variable to the higher variable. And it's the order, it's up to you to decide, okay? This order is optional. In this case, I suggest to start by the initial symbol and then, going in this specific order, but this is something optional. You can order the variables in any order that you want, but then in the following steps, you need to keep the order that you establish here. So after ordering the variables, we need to classify the productions. We have 3 types of productions for this classification. The first type is the ones that begin with a terminal. So for instance, we have this production here. As you can see, it begins with a terminal, and then we have a set of terminals and variables. In this case, it could be only one terminal. It could have a terminal and a variable. It could have a terminal and a combination of terminals and variables. But the important thing to take into account is that it must start by a terminal. And that is the first type. Then we have the second type, which is a variable that produces another variable. And this another variable can be followed by anything, by a combination of variables and terminals. But the important thing to note here is that this first variable should be higher in the order that we have established than the one on the left hand of the production, right? So for instance, if we have an S on the left hand, it could generate something starting by A, B, or C, right? And it could belong to this type, like in this case. We could have anything after the A, the B, or the C, right? Or in the same way, if we had a production rule where we have A on the left hand, to belong to this type, it should generate something starting by B or C. If we had something starting by B, it should generate something starting by C, right? And that could belong to the second type. And then the third type is also a variable that derives in another variable and a combination of things. But in this case, we go on the other direction, right? So this is a variable that is higher in the order that we have established in the second step, that generates something starting by a variable that is lower in that order, right? So for instance, here, if we had C on the left hand of the production, it should derive in something starting by B, by A, or by S. So just to summarize, right, if we go on this direction, if we have on the left hand a variable and it generates something on this direction from lower to upper, this is considered type 2. But if it is on the opposite order, from higher to lower, then it is of type 3. Right? And this is the summary. And then if the right-hand side starts by a terminal, it's considered of type 1, right? So these are the 3 different types that we have. Then if we go to the next step, after simplifying the grammar, ordering the variables, and classifying the productions, we can start to work on the different productions. And the first thing is to remove type 3 productions, right? This will be the first step, and we will go more in detail in the examples. After we have, when we have removed type 3 productions, we can work on removing type 2 productions. And then finally, we will need to transform type 1 productions, right? Because here, as you can see, all the right-hand sides of the productions need to start with a terminal, but then they must have only variables, right? So if we perform all these steps, we will guarantee that at the end, the grammar has this form. Okay, and now on these different steps, we can use two mathematical lemmas that will help us to remove these productions or to transform these other ones. So the first lemma is the substitution, which means replacing a variable with its productions. So for instance, let's say that we have these two production rules. We have A that generates the variable B and the terminal lowercase a. And in this case, if we want to remove, right, this could be like type 2 production, because it is variable A that is generating something that is higher, right, in the order. So this could be type 2. So if we want to remove this, what we would do is a substitution here. So we would just replace the variable B with its production. So in this case, B has 3 different productions. So we need to put those productions here, replacing the B. For instance, we start with the first one, and then at the end, we put what was after the B here in the original case, right? So in the first one, we write a, lowercase a, and then we put the final lowercase a. With the second one, we type lowercase b, the variable b, and then lowercase b, which was lowercase a, which was after the b here. And finally, the last production for the variable b is lowercase b. So we should put lowercase b and then lowercase a, because we are replacing the b. And as you can see, we don't touch the other production, and it remains as it was before. Now in the new grammar, as you can see, we don't have type 2 productions, right? We don't have type 2 productions. We would have some type 1 productions, like this one or this one or this one, and we should work on it. The other lemma that we can apply is to remove left recursion, right? So for instance, if we have a variable that generates a chain, let's say a chain of variables and terminals, and then we have left recursion here, right? We have the same call to the same variable. We can transform this into this type of productions and removing left recursion here. So the way of doing it is, if you think about this type of constructions, right? The type of words that this would generate is this chain at the beginning, right? Let's call it alpha 1. And then this could be followed by any number of alpha 2, right? It could be none, or it could be n. So in this case, n could be higher or equal to 0. And as you can see, this is the same that we are generating here, right? In the first rule, we ensure that we will have alpha 1 at least once, right? We will have alpha 1 at least once, and then we go to a new variable, d, that we just introduced. And in the we ensure that we have alpha 2 at least one, or it could be multiple times. So with these two new rules, we can have only once alpha 1, or we can have alpha 1 and then any number of times alpha 2, right? So it will be equivalent to this one, but removing the left recursion at the price of introducing a new variable in the grammar. So for instance, let's see an example here, right? Imagine that we have this kind of production rule where we have left recursion, right? And we have left recursion here in this production rule and left recursion here. So now if we identify alpha 1 would be the productions where we don't have recursion, right? So for instance, here would be alpha 1, and all of this here could be also alpha 1. And then alpha 2 would be the productions that are after the variable with the left recursion. Sorry, this is alpha 2. So now if we want to transform this in a grammar without left recursion, right, what we do is we follow this template. We just follow this template. So first, we just write alpha 1, which is all of this is alpha 1, right? And then we write alpha 1, but now followed by the new variable that we introduced, right? So again, we have here all the members, all the different members of alpha 1 followed by the new variable. And then in the new variable, we need to write alpha 2, right? So we write here alpha 2, and then all the members of alpha 2 followed by the new variable, right? So again, we put all the members of alpha 2 followed by the new variable. Now, every time that we introduce a new variable, this variable will be the first here in the order of variables, right? So it will be like the smallest variable. Okay, so just to summarize, we have seen that with this template, we are generating the same kind of words that with the previous one, but removing left recursion at the price of introducing a new variable. And here we have seen an example of how to apply this template, right, to a grammar with several production rules. And we have seen how it looks at the end. So these lemmas are the two tools that we are going to use on the last 3 steps to transform a context-free grammar to Greibach normal form. And these are, let's say, this is the theory, and these are all the tools that we are going to use during these exercises or these transformations. So thank you for joining me today. This was the introduction to the Greibach normal form from a, let's say, practical perspective. As I mentioned in the following videos, we will work on some exercises to be how this theory materializes into the practical approach. Anyway, if you have any question about this explanation, please don't hesitate to contact me or to ask any question in the comments down in the YouTube video. So thank you for joining me today, and I will see you on the next video. Bye-bye.